Good morning. All right. Good morning, everybody. How's it going? I'm here to talk about multicasting on 9/11 and thereafter. Rich and Prashant have been helping with this. Tonight they didn't make it, but maybe they're watching on a multicast broadcast. A lot of people know sort of the edge problems. This was from keynote rather. There were a lot of edge problems, and the meltdowns, of course, tended to happen, as far as I can tell, and from what the limited amount I could see of the backbone performance, it performed well. Certainly our backbone connections performed well. Everything seemed to be happening at the edges, and the multicasting actually performed really well, and there was a huge spike of traffic because of people's desire for news on 9/11, and I think that has certain implications. I'll go into those just a little bit. As far as we can tell, there's at least a gigabit a second that would save from using multicast, probably more. And over time, and by time I mean not minutes, but hours and days, the multicast peering and sort of stability of the network definitely declined. But this wasn't a traffic effect, as Sean pointed out. This is really a battery effect. Batteries wore down, weren't replaced, generators failed, and so on. I'm going to give a few eyewitness accounts here. You know, from myself, of course, I, like a lot of people, first knew what was going on when I turned on the television and saw the sort of dire picture of the World Trade Center in flames. There were people down at Networld Interop. Jim Martin was down there. He had a large screen display. He was actually going to do an HDTV test that day over Internet 2 at some 30 or 60 megabits a second, something like that. And instead they switched to the University of Michigan CNN feed, and things just sort of mushroomed from that. He said at one point, this is some pictures that Rich took of the screen down at Internet 2, he said at one point they had so many people around the plasma display that it was a fire hazard, that you couldn't get in or out. Now, for myself, sitting up in Fairfax, Virginia, not too far from the Pentagon, what we first saw of the multicast spike was actually a great increase in MSTP traffic. And it was so large, about 10:30 or so, we were thinking that there might be a denial of service attack going on. And Prashant, out in California, pointed out that no, there seemed to be actually an increase in real traffic. It wasn't a denial of service attack. And at the same time, I was getting emails from people in New York that were saying effectively, I have no radio except for some AM stations. I have no television. I have no internet, and I can't get anything on the internet. Where can I go to get news? And I said, well, if you had multicast connectivity, you might be able to get something there. I have pointers here, really. This is from Prashant. I think most of you can see the purple line is the one to look at. That actually represents MSTP traffic going through the Qaeda at the NASA Ames mix. And immediately after attack, there was considerably, so this represents multicast usage. Like multicast receivers and senders that are sending traffic. So a receiver is only going to do that if it's sending control traffic, which RTCP does send control traffic, and so you would show up. But there are a lot of silent receivers, and if you're a silent receiver, there's really no way of knowing whether you're getting multicasting or not, at least not from the tools we have. And it came up very quickly. This is historically pretty unusual. Seems to be mostly a daytime effect, actually. It's like people getting it from their offices or something. And then in the following days, there was a similar but not as noticeable increase in traffic. Again, mostly during the continental U.S. daytime. All right, we went back and re-looked at this, and actually I looked at the monitoring information I have, which is not as frequent as Prashant's, and you see from 3 separate monitoring locations, you have a pretty good coincidence in the measurement. So it's pretty clear that we are more or less measuring the same thing within the 10% level or so. MSTP makes this available. The new SSM multicast, single source multicast, will lose this ability, unfortunately. But I think that'll provide a considerable increase in network reliability. And again, basically immediately, as soon as within an hour, between 9 and 10 o'clock in the morning East Coast time, there was this big ramp up in traffic. From the active receivers, that is to say from the receivers that were sending control information, there was at least 1,000, 1,500 of those, and that's where the gigabit assessment came from. This is along the historical flop, the same information. You can see diurnal cycle, a lot of this is US and Europe, and then bang. And it sort of went to normal. This is actually maybe related to the nimble worms. The VBrick system has a separate system for telling you TV viewership, and that was actually 830 people at a megabit and a half a second. So that's a gigabit right there, gigabit a second right there. As far as we could tell, and now this has actually made us think very seriously about monitoring multicast, not just reachability, but multicast performance in real time. There is actually some monitoring that going on. Bill Nicholas does that, but unfortunately, that information is not really archived, and so once it's gone, it's gone. We've been thinking seriously about archiving this and making historical records available. I think that would be a good idea. But as far as we could tell from our location in Fairfax, the multicast performed well. We everywhere we tried to get to, we got to. You know, we didn't see any service interruptions, and we didn't hear about from other people. This is anecdotal, of course, but we tend to get a lot of complaints when people don't get multicast for various reasons. And we didn't hear about any of that. So, we did see, though, starting 2 days later, problems. And we were told that this was because of 25 Broadway, that when their backup power went down, they, there was a fairly important Internet 2 link going over to Europe that was not redundant in any way, and so it partitioned the network. And I wanted to talk about this from a multicast standpoint just a little bit. We actually have 3 homes or AAA homes, and you just do in the MBGP, well, how many routes are advertised by 1, 2, or 3 of those guys? Only 20% are advertised by all 3. There are 28% that only advertised by 1. Well, you got single points of failure, and I think in this current state of multicast, that is the case. That there are single points of failure because it's not as robust as the unicast. And this is a view of what happened on 25 Broadway. The attack, this is every 6 hours now, this is our monitoring data, didn't seem to really cause any problems. The day or so after the attack, I actually looked at it fairly detailed, didn't seem to cause any problems. And then when the 25 Broadway failed, bang, we lost about 10%, all in Europe, all through this one connection. And then we tried to set up a tunnel with our friends over in AECS in Amsterdam, and we sort of kept bringing that tunnel up, taking it back down. That's why you have these sort of weird patterns. We hadn't done that, and we just been flat and low for a considerable period of time. It wasn't restored for almost a week that way. And so, you know, people who were trying to get multicast connectivity through that single point of failure would have had problems. So in conclusions, I'm going to try and keep to the schedule here and see what's happening. I think multicast passed the real baptism of fire. It performed fairly well. We didn't see any problems. We thought there was a denial of service attack, but there wasn't. That was actually usage. And it saved quite a lot of bandwidth. And I think the other conclusion I've had is that if you're really going to start thinking about using these things, as people are, for some sort of emergency broadcasting or emergency notification, then it really needs to be made a lot more robust. Right. Thank you. Time for questions?
Questions from Marshall.
Comment. Correlative says with SSM, you do not necessarily lose RTCP information because you can use unicast-based RTCP. If it drafts up in the IPS, and IPTV does it already have the information.
Well, yes, I'm well aware of that, but that See, the MSDP makes it naked for anybody to pick up on. With SSM, only the source would know about it. I'm not saying that's a problem. It's just from a monitoring standpoint, you know, it's something we use. Sean?
You mentioned making the multicast more robust by adding additional mesh or peering. How easy is it to detect that the alternate paths exist through multicast in advance?
From a static point, it's not a problem. You know, the MBGP will tell you how many routes exist the same way it does for unicast BGP4. So, I mean, it's you know, the deeper problem of saying, do all your connections go through the one fiber location in one building? I think that's really the same problem as unicast. I don't know how you'd say that really for unicast. I've heard all kinds of stories about people who thought they had redundant fiber and they found out it was on the same conduit or whatever.
Well, my question is more about your one slide where you showed that there was X percentage had 1, X percentage had 2, X percentage had 3. Yeah, that slide there. Is it simply a matter that we now need to bring that to people's attention? They weren't looking at that before? Or was there some difficulty that ended up being that way?
Well, I think this is just indicative of the limited amount of multicast deployment. The multicast deployment is limited. It's about 10% of the total internet. And so you're basically doing that within a network. I mean, if you just think about it, you've got 3 unicast links to a given location, or 5, or whatever number, and then only 1 in 10 of those is used for multicasting, then you're less likely to be robust. So more multicast deployment, I think, would fix that. I guess that's all my time. Thank you again. Yes, sir. I can't see you, but I know you're back.
Yeah. Several of us were wondering what you did differently on the 11th as compared to the other days when, all the other days of the year when multicast was not working well.
Well, I don't know. I mean, not working well is I don't know quite what you mean by that. Multicasting has certain problems and it has certain advantages. It was designed to handle large spikes in traffic, and it handled a very large spike by terms of traffic pretty well. Multicasting is new technology, and relatively new technology, and like a lot of new technologies, there's a certain learning curve. That's our experience, certainly, that when you first get it going, it takes a certain amount of fiddling and learning to get it going right. And once you get it going right, it tends to just sit there and work. I know ours just sits there and works. See somebody in the back. It's hard to see from up here, so it's blinding. Go ahead.
Hi, I work at Akamai, and on September 11th and 12th, we saw tens of gigabits per second of peakish traffic hitting. And while a lot of it was streaming, an awful lot of it was HTML overload. One of the interesting things was that one of the things that were getting crushed were actually just the web servers themselves unable to deliver. And are there things that people are working on in the multicast world that would allow people to deliver sort of web content? A lot of the user base of the world still doesn't really have the ability to pull in hundreds of K per second of streams. So that, in terms of peak traffic, that was my question.
Well, yes, you certainly could, and there's actually some protocols for that. People haven't really pushed it very much because they haven't seen that as a goal. But I think, there's been a discussion, and if anybody's interested, they should see me afterwards. There's been discussion about how do you set up emergency notification, emergency broadcast, and that has several aspects. One is news. For that, you might well want a TV feed if you can afford the bandwidth. But the other is just simply text or HTML, or the president has announced that the air traffic control system is shut down. And I think it's really not so much bandwidth you care about as reliability. It's not a high bandwidth thing, 100 bits a second maybe. You just want to make sure it gets there. And actually, I think both the CDNs and multicastings